So in section 7, we're going to talk about multiplying and dividing radicals. Now, when it comes to multiplying radicals, we kind of already did a little bit of multiplying radicals, but now we're going to do a different form of multiplying where we follow the same rule as polynomial distribution. Multiplication, where we're using distribution and FOIL. And now they do have to be like radicals, so they have to have, in a sense that they have to have the same index. So both square roots, both cube roots, etc. And then we want to make sure we simplify if possible. So our first example is the cube root of 2 times the cube root of 4 plus the cube root of 12. So I'm going to take my cube root of 2 and distribute it into the parentheses. And we get the cube root of 8 plus the cube root of 36. Now I need to figure out if this can simplify anymore. So 8 is 4 times 2. 4 is 2 times 2. So the 8 is a perfect cube root. 36, I know is a perfect square, 6 times 6. I'm going to break it down as 3 times 2, 3 times 2. Now, there are two groups of 2 numbers, but I don't have a group of 3 numbers. So the cube root of 36 doesn't actually simplify, and we end up with 2 plus cube root 36. Next we have 2 plus 3 square root 7 times 4 plus square root 7. So we're going to use the same idea as multiplication, where everything in the first set of parentheses multiplies to everything in the second set of parentheses. So 2 times 4 is 8, plus 2 times square root 7, which is 2 square root 7. And we have 3 square root 7 times 4, which gives us 12 square root 7. And then lastly, we have 3 square root 7 times square root 7. So remember, when we multiply a radical by itself, so we have square root 7 times square root 7, that's square root 7 squared. And when we square a square root, they cancel. So it's just going to be 3 times 7. So now I want to combine like terms, multiply, all that fun stuff. So 2 square root 7 and 12 square root 7 are like radicals. So 8 plus 14 square root 7. And then 3 times 7 is 21. And now I can do 8 plus 21, and I get 28 plus 14 square root 7. And that's my final answer. Now we're going to an example where we have to use that expand rule that we talked about with polynomials. So we have -2 minus 3 square root 6 squared. So I have to expand this first. So it's going to become -2 minus 3 square root 6 times -2 minus 3 square root 6. Now I'm going to do the exact same thing as the last example. Everything in the first set of parentheses multiplies to everything in the second. So -2 times -2 is going to give me 4. Then -2 times -3 square root 6 is going to give me 6 square root 6. Then I have -3 square root 6 times -2, which is going to give me 6 square root 6 again. And I have -3 square root 6 times -3 square root 6, which is going to be 9 times 6. So we get 4 plus 12 square root 6 plus 54, because 6 square root 6 and 6 square root 6 are like radicals. And I'm going to do 4 plus 54, so I'm going to get 58 plus 12 square root 6. Now, I don't have to write it with the number first and the radical second. I just chose to do that on these last two examples. So 12 square root 6 plus 58 is also a correct way to do this problem. And then I'm not going to do this next example, mainly because we're not going to see any problems like it on an assignment or an assessment, and it's just a little bit more difficult than you're going to see on anything we do. So next what we're going to do is we're going to do something called dividing radicals. And the dividing, notice here, is in quotations because we're not actually dividing like the traditional sense. So because we don't really know in math what it means to divide by a radical. I know what it means to do 4 divided by 2. I'm taking a group of 4 and I'm splitting it into groups of size 2 to figure out how many groups I have. Dividing radicals is like, what does it mean to do 4 divided by radical 2? How do I split something up into groups of square root 2? So we do something called rationalizing the denominator. And I'm specifically going to talk about right now if we have a single radical expression. So that means we're dividing by a monomial, which is one term. So what we do is we multiply the numerator and denominator by the radical that appears in the denominator. So by doing this, I create a situation like that first example where I said with the square root 7 times square root 7 deal, because I multiply a square root by itself and it cancels the square root. So the whole entire goal of rationalizing the denominator is to get rid of that root. And then I'm basically moving it to the numerator. So for our first example, 1 divided by square root 2. When I rationalize it, I multiply the numerator and denominator by my radical, which is square root 2. So my numerator becomes 1 times square root 2, which is just square root 2. And in my denominator, it just becomes 2 because they cancel. My second example, I have 12 over radical 28. So I'm going to multiply the top and the bottom by square root 28. And my numerator becomes 12 square root 28. My denominator is just 28. Now, I do have to do some simplifying here. There's 2 things I have to simplify. I have to check to see if the radical simplifies, and I have to simplify the 12 and the 28. So I'm going to start by simplifying 12 and 28. So both of those numbers are divisible by 4, and I get 3 and 7. Next, I'm going to simplify square root 28, which I'm going to break down as 4 times 7, and 4 becomes 2 times 2. So I have a 2. So since I've already simplified the 12 and the 28, and I now have a 3 and a 7, this 2 is now going to multiply to the 3 that's in the numerator and give me 6. Underneath the square root, I have a lonely 7, so square root 7 all over 7. And then I need to double check that I can't simplify anything else, and I can't. Your other option here is instead of simplifying 12 and 28 first, I could have simplified my radical first, and it would have become 24 and 28, which I would have then simplified, still gotten 6 square root 7 all over 7. My last example, 5 square root a all over 3 square root 5b. Now notice how my definition said I only have to multiply by the radical that appears in the denominator, and that's true. I don't need to multiply by the 3. So I'm just going to multiply my numerator and denominator by radical 5b. So my numerator becomes 5 square root 5ab, And my denominator becomes 3 times 5b. So when I go to simplify my numbers outside, I notice that there's a 5 in the numerator and a 5 in the denominator. And those are going to simplify to just 1 because it's 5 divided by 5. And my radical, 5 is a prime number. It doesn't simplify. I only have one a and one b, so there aren't enough to bring anything outside. So my numerator just becomes radical 5ab, and my denominator is just 3b now. The second type of rational denominator we have is when we're dividing by a binomial radical expression. And we multiply by what's called a conjugate. So we're going to multiply the numerator and denominator, which I'm going to abbreviate here, by the conjugate of the radical expression in the denominator. So, for example here, if my denominator is 1 plus square root 2, its conjugate is 1 minus square root 2. So the conjugate is just the opposite operation of whatever is in the denominator. So if it's a 1 plus, the conjugate is a 1 minus. If I had 3 minus square root 5, its conjugate is 3 plus square root 5. So the only thing you change is the sign in between the whole number and the radical. Now, unlike the previous examples we did where if there was a number in front, we didn't have to multiply by it, this time we do because addition or subtraction is happening. In those previous examples, all we had was multiplication, so we didn't need to include it. But now we have addition and subtraction. So our first example, we have 2 divided by 3 minus radical 5. So I'm going to multiply my numerator and denominator by its conjugate, 3 plus radical 5. And then I'm going to go ahead and write my numerator and denominator. So we have 2 times 3 plus radical 5. And my denominator is 3 minus radical 5 times 3 plus radical 5. So now I have multiplication in my numerator and denominator, just like what we did at the beginning. So I'm going to distribute into the parentheses in my numerator. So 2 times 3 is going to give me 6, plus 2 times radical 5. Then in my denominator, just like what we did before, everything in the first set of parentheses multiplies to everything in the second set of parentheses. So we get 9 plus 3 radical 5 minus 3 radical 5 minus 5. So the whole entire point of multiplying by a conjugate here, you're like, oh, well, I still have radicals. Well, positive 3 square root 5 and negative 3 square root 5 are going to cancel. And I'm going to end up with 6 plus 2 radical 5 all over, and then 9 minus 5 is going to give me 4. Now, just like the previous example, I now need to check to see if my radical can simplify and if the numbers outside can simplify. And 6, 2, and 4, my numbers outside, are all divisible by 2. So it becomes 3, 1, and 2. Now, square root 5 can't simplify. So I'm going to end up with 3 plus square root 5 all over 2. Okay. Last example is we have 3 plus radical 2 all over 6 minus radical 2. Now remember from the definition, when we multiply by the conjugate, it's the conjugate of the expression in the denominator. So we're going to have 6 plus square root 2 as my conjugate of the denominator. So in parentheses, I have 3 plus square root 2 times 6 plus square root 2 in my numerator. And my denominator is 6 minus square root 2 times 6 plus square root 2. In my numerator, I'm going to distribute everything in the first set of parentheses multiplies to everything in the second. So 3 times 6 is 18 plus 3 square root 2 plus 6 square root 2 plus 2. And in my denominator, everything in the first set of parentheses multiplies to everything in the second. And I get 36 plus 6 square root 2 minus 6 square root 2 minus 2. So nothing is going to cancel in my numerator, but my 6 square root 2 and my negative 6 square root 2 are going to cancel in my denominator. And I get 20, because 18 plus 2 is 20, plus 9 square root 2 in my numerator, all over, and then 36 minus 2 is 34. Now 29 and 34 are not all divisible by the same number. 20 and 34 are divisible by 2, but 9 is only divisible by 3. So, and then the square root of 2 doesn't simplify, so this is going to be my final answer. I know that dividing in quotations is a little bit more difficult than multiplying, so we are going to be doing a couple more examples of the multiplying and dividing in class before you practice on your own. But let me know if you have any questions over multiplying or dividing radicals.